Alright, there's going to be a series of videos with very similar problem types where we deal with intersecting chords or secants or tangents or some combination of these things. And here we have two intersecting chords. There's a pretty simple relationship when you deal with these types of things. In fact, all of these will be very kind of minute equations. They're really simple, straightforward, but there are quite a few of them. And while they have some similarities, there are also enough differences that can be kind of tricky to keep up with. So for this one, we're going to have a really nice, clean relationship. What you can do is actually multiply the segments together and see that they actually end up kind of breaking each other up in a similar way. So for example, here I can multiply the 7 and the 15 together, and whatever I get will actually be the same value as multiplying 3 by whatever the length of IL equals. And for the sake of this problem, let's just call this length x. It's a pretty traditional thing, just using x to represent what we're looking for. So what I said here was that the segment HI times the segment IJ, so that's this 7 here and this 15 here, and yes, this is not drawn to scale. On this side, I'm going to say, well, KI, if I multiply that by IL, so that's the smaller parts of the other chord, these will actually be equal to each other. They break each other up in this kind of fascinating way. And if you can keep up with that, if you can kind of put that together really quickly, then this is a fairly simple problem to do, actually. Because all I'm going to do is replace all my values. HI was 7, IJ is 15, KI is 3, and we're trying to figure out what the length of IL equals. And another thing I like about this problem is the numbers are at least a little bit clean. Some people will go in and they'll try to multiply this out and make it large at first. What I would like to do is actually go ahead and divide both sides by 3. Because I can figure out the length of IL simply by saying, well look, 15 divided by 3 is actually just 5. And notice that I've shrunk my numbers down instead of making them larger first. Then most people are pretty comfortable telling me 7 times 5 is 35. I think I would have a lot of trouble with some people telling me what 7 times 15 was. I think a lot of us would have just grabbed a calculator there. But a lot of people can tell me 15 divided by 3, and they can tell me 5 times 7. So I kind of like shrinking my values when I'm simplifying a problem as best I can. And then if you wanted to verify that, if you weren't sure, then all you have to do is just grab a calculator real fast. You don't even have to think about it. This way you can kind of not worry about making mistakes yourself. 7 times 15 was 105, and 3 times 35 is 105. That's how I know I've done this correctly. Because if I came over here and said, well, this is equal to 35, then it's supposed to be that 3 times 35 equals 7 times 15, and we see that very clearly here in the calculator. And there you have it. That's how you deal with intersecting chords.